All right. Thanks everyone for joining my routing and switching video series. This is going to be part three for the BGP path load balancing configuration we have been doing. So I've created part one, part two, part three. So this is part four. So I highly recommend you to go back and watch part one, two, and three to get a clear understanding what I have done in those part one, two, and three. So just to give 32,000 feet high level overview what we have done in those videos. So basically on my left, I'm sorry, on my right I have Dallas office, and on my left I have New York office. And this is my external switch, the core switch. Behind that I have my networks 1.1.1, 100.1.1, and that is connecting to my edge router, the router 4. And this router 4, between this external switch and router 4, I have OSPF running in, and that's how they are sharing their routes. Then router 4 is connected to the external world, external networks, to router 2 and router 3. Those are ISP 1 and 2, where again the router 3 and router 2 are connecting to the router 1 in New York. So basically New York and Dallas is connected through ISPs, the cloud internet, using ISP1 and ISP2. And the whole goal of this video series is to uh, prove to manipulate the BGP path selection when a BGP router has multiple paths to reach to its destination. How we can change them. So in part one, what we did was we configured everything from the scratch, the routing part. We configured the OSPF, the BGP, eBGP. In part number two, what we did was we redistributed OSPF into BGP and BGP into OSPF. And part number three, what we did was router 2 was preferred for moving the packets between New York to Dallas. So we changed that to router 3, and we made the router 2 as a secondary. There are multiple ways of doing it, but in part number 3 we used AS path prevents to achieve our goal. So in this series, the part number 4, we're going to use another mechanism called local preference, where I would configure on the receiving end. So it's like source is Dallas and destination is New York. So on the receiving end, I'm going to put this local preference. First we'll see the New York router, which path it's selecting to get to the Dallas. So if I quickly hop on to the router 1, if I do, I have done already, as you see on the screen, show IP BGP. These are my Dallas networks 1.1.1 and 10.1.1. And as you see here, 1.1.1, it has two routes, 20.1.1.2 and 10.1.1.2. And this is the preferred and the best is 10.1.2. That means it is preferring router 2 to get to the Dallas 1.1 or 100.1 networks, as you see here. There you go, 10.1.2. So let's make router 2 as a secondary and router 3 as the primary. As you see here, 2.1.1 is there, but it's not preferred. You don't see this, right? Star and the greater than symbol. So let's do that. So how are we going to do that? First, we'll create a roadmap and put a local preference into that. So that in the receiving end, we'll put more preference onto the link. Router 3. So let's do that. So conft, let's do show route map. Let's see if I have any route map. We don't. So conft, we'll create a route map called Dallas, right? And permit 10. That's it. So again, from here you can either create IP prefixes and add those IPs into the prefix and the different sequence number 5, 10, 28, etc. like that. Or what you can do, just create a route map and put it in. If you just put a route map, basically, if you say permit 10, it will allow everything on the route map. In the future, you can create a prefix list and bind them and call them in the route map. So I'm not going to do that. I'm just calling the route map and saying permit 10. That means I'm permitting everything on the inbound wherever I put this route map, right? Hope that makes sense. Okay, so now that our roadmap is created, make a habit to confirm whatever the changes you just configured to see those are actually present. So show roadmap Dallas. Alright, so I have a roadmap Dallas here. One thing I forgot to do is um, let's do that. Put a local preference on that. So just copy this roadmap Dallas. Sorry, sorry there. Set local preference. I will call 200. We'll increase the preference to 200. And right now let's put this roadmap onto the receiving end of 200 so that this will become a primary. Now the 10.1.1.2 is primary. Show IP BGP. Let's do show IP BGP 1.1.1.1. So the preferred one is 10.1.2. As you see here, best is number 2. So let's put this nuclear roadmap to increase the local preference um, on 20.1.1. So it should show here number 1 instead of number 2, or at least point to this IP, this peer as a primary and the best. So show run sec. Let me do this first. Show IP BGP summary. Right. So I'm learning 3 prefixes from neighbor 10.1.2 and 3 prefixes from neighbor 20.1.2. Just to confirm that, right? So I will do show run sec BGP. Oh, right. So this is my BGP configuration, right? Nothing fancy here. Very simple. So conft. Let me copy everything from here on a BGP 100. So we will be influencing the path on this neighbor 20.1.1.2. So we'll copy that. Route map. What was the name of my roadmap? I prefer to go and copy exact the same thing, just to avoid any typos or anything, and I will call in, then end. So let's go and check my BGP configuration again. So now you see that I have a BGP, I have a route map on this neighbor 20.1.1.2. As you see, let's do show IP BGP summary. We still have three routes. Show IP BGP 1.1.1. Still pointing to 10.1.2, the number 2 here. So let's clear the IP BGP, clear IP BGP SOP. Alright, let's see what happens. Okay, so now as you see here, the best is this one, the number 1. Best path is number 1. We still have 2 routes to get to the Dallas network 20.1.1.2 and 10.1.2, but now the preference has changed to the number 1, 20.1.2. That's what we intended to do, right? If I scroll back up, before we made the change, let me expand this one real quick. Where did it go? Where did it go? Show IPBGP. Just bear with me for a second. Okay, here you see that show IPBGP 1.1.1, which is the Dallas network. It was preferring the, even though we had the same 2 available paths, best is number 2. That means this one, the second one, 10.1.1.2. So as I said, this is the preferred path, and let's make this as a second preference and make this as a primary preference, right? So that's what we just did. We created a roadmap and we call that in our inbound neighbor interface, and so we still have 2 available paths, and best is number 1 now. So we swing that primary path to secondary and secondary to primary. So let's move to best is number 1, which is 10.1.2. Hope this makes sense to y'all. I want to keep this simple, and yeah, just want to keep this simple, and hope you like this. If you have any questions, leave some comments, or any questions you have, feel free to post. I will try my best to answer them accurately. So this video is what I'm creating and posting here. Were requested by my followers. They have questions about BGP path manipulation or BGP load balancing, how we can manipulate those paths, how we can change the BGP default behavior and customize manually based on the requirement. So don't forget to subscribe. Hit that thumb icon, hit the bell icon, so every time I make a video, you guys are updated on that. All right. Thank you all. See you in the next video. Thanks.